Good day, everyone. This will be lecture number 6 for MGC 110, and then for section of manufacturing, this will be lecture number 2. We are starting now with specific methods of manufacturing. And remember, in the first lecture for manufacturing, we spoke about, it was just general introduction to manufacturing. So the first method that we are going to be speaking about today will be casting. I'll go into details around that, and then we will get to see where it is applicable. Just to run a few things around how you can approach this. A lot of information is in the textbook. You can read your textbook, you'll get a lot out of it. And then you can cascade that with the class notes, which are just extracts from the textbook, and then with that you will use this video. We are going to start now with the session. So, casting. What is casting? Casting is when a molten material which is in the liquid phase, so you will melt a material, is poured into a shape holding mechanism or structure, and then it is left to solidify. Then that solid will become a part, and that part is produced through the process of casting, and that part is called cast. So let's just think about it along those lines. The process where we pour the molten material into a shape, and then we let it solidify, and then we remove the shape or destroy the shape, and the part that is left which has solidified become our part, and then that is a casting product. Okay, so that is the explanation, both explanation on what is casting, molten material, and then the mold is then removed to expose the new part. That is the destruction or removing the mold. So the part that we formed to pour our molten material in is called a mold. The part that is going to form in the mold is called casting. Okay, we have expandable molds, and then we have permanent molds. So the expandable mold, you form the mold, you pour your molten metal, you solidify, you destroy the mold, you take out a part, then you make a new mold. That process is in that cycle. The permanent mold, it's you just remove it and bring it back. So it's more of you can already start thinking of automated systems here. You will see as we go into details about what it could be. But one of the characteristics for expandable mold is that the production time is a little bit less as compared to permanent mold. Between these two processes, sand casting is the one that is mostly used. I think this is because of its age. So it is one of the first to be used. For sand casting, we use sand to form molds. So we will form, just think of your sand houses that you will build with a beach sand or something like that. That's a relatable example of sand casting. So you make a shape using a sand, and then from there, if you want to take out your shape, you destroy the sand, and then you take out your shape. But you'll see it's a little bit a complex one if you look at it into details as to what could be this process. From what we just learned now, you wouldn't be able to comprehend exactly what happens. Okay, you have a pattern. These are the external shapes that you form, so that you can you will use this to make molds. You can use a wood or a metal or a plastic. So you should make it in such a way that you can be able to remove. So you will take a pattern, and then you put sand on it to form a shape of that pattern, and then you remove the pattern, and then the shape that it has left on the sand, you will pour your molten metal on to create this a similar shape of the pattern that you removed. And then in order for you to take out that shape, you need to now break the sand. You can use wood, metal, or plastic for this. I mean, the advantages rather of using metal, as you can see, it will last longer. We know that metallic components, they tend to last longer. You can have solid patterns, you can have split patterns, matching plates, core and drag. These are all because of different shapes that you need to make. So you'll make your patterns will actually follow the shape that you need to make. If your shape is complex, you might need to have split patterns. And then if you have maybe a solid pattern where your component is solid and then you just need to remove it, you can have a solid pattern. Therefore, you'll be able to remove your pattern and then pour your metal, then break the sand or something like that. Core and drag, you'll see, I will just explain them now. But basically, the core will be the top, and then the core will be the top, and the bottom will be the drag pattern. Let's look at this. So you'll have there a pattern. This is a shape that you want to make. You will put it in the core, into the drag. Okay, let's go back a little bit. So you have a cope and a drag. This will be part of the split pattern where you have the mold, the cope and the drag. This will be the side of the mold, and then the pattern is the shape. So if we go further here, the pattern will be, look at this. This is your pattern. This is what you need. You want to reproduce similar type of components, and then you have here the drag, you have here the cope. The bottom part will be the drag and the top part will be the cope. And then there you have your sand. Then you have your core. If you need a core, it will form a shape. A core will be a shape. You have a riser there, you have a sprue hole. So that is just the basic components of the casting process. Okay, when you're making a mold, remember we said a mold will be the shape that you make so that you can be able to produce casting products. Okay, this will be a pattern, and then you're gonna use patterns to make the molds. Then you remove your patterns, then you pour your molten metal to make that shape again. Think about it that way. You see there, keep note of a riser and keep note of a vent hole there. Very important. They help us with other processes. Here is just to vent your air out so that you can fill up all the way. And then the riser will also be helpful to tell you that now your cavity is filled up with your molten metal. You pour on one side, you just look at on the other side. Maybe just to note you guys with something, there will be videos on this about these processes. You can watch those, or you can just simply go to YouTube or Google fundamentals of casting process. You'll see all this aspect highlighted. Okay, we go on. This is a solid pattern. This is the split pattern. You have plate patterns and then many other type of patterns. So there they are: match plate, cope and drag. And then let's go further. Here's another method. You should just keep note of this. Here you have a core. A core will be if you have to make any shape that has internal surfaces that you need to form from casting process. So you have there a core, you have there the cavity, and then there you have chaplet. Chaplet is just a support, type of a support that you need. And then let's see, you have a riser there. And the shape that you can make out of this will be something along these lines. Okay. And then chaplet, you can melt them, or if you still have them on your component, you can imagine this will be submerged into your component. Ultimately, you can cut it out. Okay. And then this thing will ultimately, you can be able to remove the core because it's sand, remember. If it's sand, it's made up of sand, you can just simply remove it, destroy it. That is the reason why we use sand actually. Is that at the end we want to take out this from the inside, therefore to get to the inside we just have to destroy the sand. Okay, sand casting, we will have a sand which can have different properties depending on the application. Silica, you have high sand, then you have grain size permeability. These are the properties that you will be looking at from the sand, will define ultimately what you need to consider in order to choose this type of sand that you're going to use to make a mold. Okay, here you have water and clay. Okay, maybe let's just say in the sand you can look for silica, high temperature applications, grain size permeability. This will also help you with the surface of the component that you are making. Okay, you can have water, clay, or bonding agent mixture, green sand, dry sand, skin dried, no bake molds, and then remember all these are applicable to different methods of performing casting. Okay, flask versus flaskless molding, high production rate. You'll get to see what these methods are about. Shell molding, they are just indicated that maybe the origin was Germany, and then the different types. Start with shell molding. Shell molding saves a lot of sand. Let's say the type of okay, let's maybe go by going through this process, we can be able to understand what we are trying to achieve with this type of molding. So the first one, you'll have a sand which you need these properties around your component, your final component over here. You will have a sand there, put a shape, this will be your pattern, and then just turn it around and then compact it around here and then turn it back up, and then some of the sand will drop, and then you'll have this formed shape over here. That will be your shell. Then you remove over here, you heat it up just to make it more solid. You guys should know by now there are processes when you want to make harden your bricks. It's a process where you have to heat them. You can just go also find out what are the benefits of those, but just to make it a strong product. Then you remove your pattern. You are left with a shell which is going to form your shape here. That is your mold. Then you bring it in to contact with whatever shape. This will be a half pattern probably. Then you bring it in. When you bring it into the shape, you have two of those, and then you can just pour some sand, which is not going to be a similar type as this. Just pour that into that. This will give it strength. Once you start pouring your molten metal, you won't break it if you have it supported with a different type of sand. And this is your product out of it. The advantage that comes with this type of molding procedure will be good dimensions, which accuracy becomes an important thing. Remember, because of sand grains, you can have different accuracies out of your molds, which is why sometimes it's very important when you do molding, casting procedure. You want to have your cavity a little bit bigger so that you can allow for shrinkage, because when materials cool down, they tend to shrink. And then for that reason, when they are in a molten phase or in a liquid phase, let's put it that way, they will expand a little. Also, you want to make them a little bit bigger so that when you machine them, sometimes when you do the casting process using sand, you will find that your surface finishing is not what you need. Therefore, you need to file them out or maybe machine them using whatever method of machining that is applicable. Then you bring machining into the process, and then you start taking out the material. While you're taking out that material, then you are left with a perfect dimension for the part that you were looking for. So you need to allow for that during the design and manufacturing process. Okay, the other things that, okay, it's more expensive to make their patterns, but you can produce in large quantities. You have another one here called vacuum molding. You'll see the process also in the next slide. Okay, recovery of sand with no binders. Binders are the mixtures that you put into the into the sand. Binders will be the mixtures you put into the sand so that it can form a nice mold. For this one, it's easier to recover your sand. You won't have any defects due to moisture that you find in the sand, and but it's a slow process, so it is not easy to mechanize, which is going to make it difficult to use, maybe let's say automation processes. But with time you realize that you can have a lot of methods to implement on these procedures so that they can become automated, or using machines. And then vacuum molding, as I said, you first have your pattern over here, note the holes there, and then you have a plastic sheet. You just bring it here. This is a vacuum drawing hole. With that, you start drawing your hole just to keep the plastic around this pattern, and then you pour your sand. Then you seal it again. Over there, here you seal it again, and when you seal it, you are connected at the top there. You have you can pull a vacuum through this hole here, and then you can let go this hole, and then over this, with this process, you can let go this pressure, negative pressure, and then start pulling over here. This, when you start pulling with this, you will only be maintaining this shape. If you can, okay, if you start pulling over here with you sucking out probably air pockets that are there, you will just retain this shape, and then you can be able to remove. Then you will be left with this shape over here. This is the shape of the product that we want. You then bring a second, so you'll then bring, remember we used, for this one we used plastic. You'll then bring your molten metal in. You pour it in to form your shape. There is your shape formed. After you are done with this, you can destroy this, or you can just let go the vacuum and then break your sand. Then you will be able to get your part out. So basically, you form this one. You used vacuum to form the mold, and you just break it by releasing the vacuum. So because you don't need any material or extra mixture material to make this sand hold onto your shape or retain the shape, it's easier to recover this sand. You can also have this one method here, polystyrene process expandable. Also, you have the polystyrene there. When you pour this metal, it will melt away this polystyrene, escaping as a gas. These are vents. So your vents are there to allow air to escape in the process. So you will have your air escaping. Remember, sand also has pores, so that is it's made possible by sand as well. Okay. You can then afterwards you can allow it to solidify, then destroy your mold, then you get your part out. This will be the part that you can make out of that. So just check there. You have here your mold box, which is just sand, depending on the shape, of course. This one, it's easier because you're pouring from the top, and then the gases are gonna be released at the top, so it's easier for this one. So you don't need, remember I said you need vents here. For this one, this is also serving as a vent. Ultimately, you will have your molten metal filled up here. Then you will have your shape after solidifying. And here they're indicating something, because you can melt this. The patterns, you don't need to remove them afterwards. You can just bend them, and then they will come out. It can come out as liquid. Maybe think of it like this. Let's say you have this material here. It has a lower, you can solidify it, but it has a lower melting point. Then when you bring in a metal with a higher melting point, it will melt this material before it can solidify, melting this, and then with density, higher density, right? Because of density, it might go down, and then lower density come, and then the material with lower density comes up, and then it escapes. So that is another approach you can think of. So you don't need to remove the pattern. You will melt it, and then it will escape from the top. The metal going down and then settling and then forming that part you need. You also have something called investment casting. This one is good when you want to produce multiple complex shapes. Accuracy, and then it can go into finer details as well. It works the same way as the one that we just had in the previous slide. You form this will be your pattern. You form your patterns, you remove them, they formed your shape there, and then this is your what you use wax, and you here is called wax sprue. This is just a connection point. You put them, you have your wax sprue which has the wax pattern, then you now immerse this into some material that will allow your sand to form, to take shape around your mold. There is the sand at number 4, and then afterwards you can now melt the wax out. Once it's out, it will leave a shape formed from there. And please note over there the holes, how they are formed. This will allow you this hole will be useful when you fill up the cups. Let's call this the cups. And then this hole will be used when you remove the wax. Okay, you pour your molten metal, it will take the shape, then you break the sand. This will be the sand. You break it up, you take out your shapes. Close dimensions will be achieved. Good surface finishing is also achieved. Wax recovery, you can also reuse your wax. And then you have if you have it formed nicely, you don't need to machine this further to make it a proper product that you're looking for, but it's expensive. You can achieve small sizes using this procedure. Remember, I said we have expandable mold, and then you have permanent molds. We are going to start now with permanent mold casting. Usually you would use but I'm going to explain this so that you can understand the meaning behind this. Usually you'll use a shape that you can open. Remember the drag and a cope that we had in the beginning of this session. So the drag and the cope, you can have them on a permanent mold. You can have them made permanently. When you are done with your molding, instead of destroying your mold, you just open it and take out your part, and then you bring them together again. Think of having a shape that can produce simple components. So you just this will be the side of the component, and then the top of the top of the component. You bring them together, you pour your material, it solidifies, take it out, and then that is the process with permanent molding. Usually it works, it has high rate of production, and then it works with opening and closing, never destruction. Okay, let's continue with this. Check there the procedure, simple procedure as to what could be the procedure. You have a piston there just to actuate, and then retract and then expand, retract, expand, retract, expand. That's just your cylinder. And then you have probably get in the design of this will allow you to have stoppers so that you can have the exact shape. So you'll expand your piston or push it to get to a shape where you need. You pour your molten metal, then once it has solidified, you remove this, you push it out, you push your part out, then that's your part. That is permanent. This will be repeated many times before you can replace this shape over here, or this one over here. And then this will just indicate that this is from the ground, and this one doesn't have that, so it can move in and out. This is just to show you that you can push in and out ground, and then you can push this in and out. Advantages of that: good surface finishing, close tolerances, more rapid solidification, that's strong casting due to small grain sizes. Okay, limited to low melting temperature. What it means is that if you're gonna use high melting temperature casting, molds, then you need to, in order for you to be able to use that, you need to pour inside if your molds are made up of metal, which is the case, right? This, you use metal most of the times to make your molds. They need to withstand temperature of the molten metal that you are going to form. So this, if it's at the same temperature, it is going to melt your mold. Therefore, you need it to be a little bit less melting temperature. So the disadvantage you have to the molten metal should always have a lower melting temperature, simple part geometry, expensive mold. But though it's expensive, high production rate. So your plate, you can simply use this type of approach. Okay. You have different type of permanent mold casting, slash, low pressure casting. I'll give few details around what each one mean. And then you have on slash, you have a hollow casting, which is formed by investing the mold to drain after partially freezing at the mold surface. So you will have here, you will see this. I'm going to explain this better when we get to centrifugal casting. But basically, you can think of a shape. You want to make a hollow shape. You want to make a hollow shape, but outside it has a nice shape, and then inside you don't really care about the surface finishing of the inside of that. Let's say it's a ball. On the outside, you will make a shape of a ball, and then you are looking for close tolerances around this ball. And then inside that ball, you don't care about the shape and the thickness as to what the tolerance of the thickness inside that ball, but you are only care about the shape on the outside. So what you will do, you will pour your molten metal and then just rotate the mold. You will pour your molten metal and then just rotate your mold. As you rotate your mold, the molten metal inside will be moving around to the surfaces of the mold. Inside it will be forming a hollow space. And then once you are done, you are sure that now your molten metal has touched the surface of the mold, and then you can leave it to dry up, and then you can destroy it. If we cut that shape, that form, if we cut that formed product out of slash casting, you will find that inside it has the shapes, they are not very nice, or the dimensions. You wouldn't find a perfect circle, but on the outside where it was touching the mold, where the molten metal was touching the mold, you will find a perfect shape that you are looking for. Then we have low pressure casting. They use pressure here to just generate your shapes. And here I'm trying to explain something. This one works exactly the same as vacuum, except the vacuum will be pulling and the pressure will be pushing. Think about it. So you have a shape here. If you supply enough pressure, its liquid form, then this molten metal will start rising into whatever space that is available. With the vacuum approach, instead of pushing from this side, you pull from this side, somewhere over this side, and then it will pull this molten metal to fill up the shapes that where you'll be sucking your air from. Or ultimately, you'll start sucking your molten metal. So you'll have enough control so that you avoid sucking into your sucking system. You'll avoid sucking your molten metal. Then you also have this one called die casting. Die casting is just a permanent casting procedure, which maybe I can say you can automate this. Okay, on the die casting, you apply high pressure, and then you maintain your pressure for the strength properties of the product that you are looking for. And then with these machines here, you can easily achieve high pressures. So you must just read into a textbook as to what pressure limitations are for this type of methods. But maybe let me just explain it. You have hot die casting and cold die casting. Hot die casting, in a hot die casting, you'll have this pot which is heated up. But basically, this is what you have here. You will push your molten metal, and then it will go into the shape. And then once it has solidified, and you can imagine once you have filled up this cavity here with enough molten metal, you can then pull back your plunger, and then your molten metal will go back, and you continue heating it up. Once this one is solidified, you can remove the part. This will be cleared, and then you put it up, you push back again. The process will just run like that. Look at it here. Once you get here, push up until to a point. Whatever that will be left here will be heated up once you retract, because this is continuously heated up. The chamber is hot, and then you push up, and then when the plunger goes up, the molten metal will flow in, push back in. So you can automate that. Cold one, you pour your molten metal in instead of having this whole process continuously being heated up. That is the true difference of those two methods, but they actually just do exactly that. The advantages of die casting: high production rate, economical for high production, close tolerances are possible, good surface finishing, thin sections are possible, rapid cooling, and then the disadvantages of this would be shape restriction, high volume process. And with that, that was everything that I had for you guys for casting 1. We are going to continue with this in casting 2, and then I'm going to post under under manufacturing, under lecture, or under casting, probably put more videos, links to the videos that you can watch to kind of understand as to what is casting and the process in general. Thank you very much, guys.